Hi, my name is Jemu. I'm an APEC migration lead in Global Financial Services team at Amazon Web Services. I'm specializing in large-scale migration and modernization, and we are so glad to have you joining us today for the ASEAN series of technical breakout sessions. In this particular session, we're going to find out how we can simplify multi-environment deployment using CDK pipelines, along with the demo. This is a 200 level session, and we are going to cover 4 topics. First, we'll go through infrastructure as code overview. Second, we'll find out why multi-account, multi-region deployment becomes popular, and what are the considerations in this use case. And then, we'll check how CDK pipelines can help simplify the multi-environment deployment without dealing with complex underlying configurations. And finally, we'll go through a demo with the actual code to see how it works. Let's get started. One of the foundational elements in DevOps that enables speed and consistency of software delivery is being able to deploy infrastructure consistently and reliably, over time and across teams. Many organizations rely on manual processes or complex scripting for environment provisioning and configuration, making it difficult to be consistent, have a single source of truth, and detect or remediate infrastructure provisioning errors. Customers need ways to consistently automate infrastructure provisioning and configuration, manage the infrastructure lifecycle, and share best practices throughout the organization. Infrastructure as code enables organizations to define their desired infrastructure using a configuration file or code, and programmatically create it to ensure consistency and repeatability. With infrastructure as code, customers can manage the lifecycle of resources. They can host infrastructure definitions in version control repositories, creating a single source of truth and capability to share and enforce best practices, and the capability to roll back changes to an earlier version. Changes to definition files can take advantage of continuous integration and continuous deployment in concert with the application code to keep environments synchronized with infrastructure as code changes. AWS offers AWS CloudFormation and AWS CDK to make it easy for customers to leverage infrastructure as code on AWS. CloudFormation lets customers use YAML or JSON to define templates that model a collection of related AWS third-party private resources, provision them quickly and consistently with the support for drift detection and failure rollback, and manage them throughout their lifecycle. Alternatively, customers can use Cloud Development Kit to model their infrastructure in languages such as Python, Java, .NET, and TypeScript. It provides high-level components called constructs in class libraries that pre-configure cloud resources with proven defaults. It also allows you to compose and share your own custom constructs, incorporating with the organization's requirement, helping you expedite new product. AWS CDK provisions your resources in a safe, repeatable manner through AWS CloudFormation. An AWS environment generally refers to a combination of an AWS account and region. And as your workload grows in size and complexity, most of our customers are using multi-account, multi-region environment due to several reasons. Resource isolation for all of the applications, workloads, and business units. Lowering the area of impact to your applications and resources in the possible events such as service disruptions or security breaches. Separating workloads into different environments to manage service quotas. Restricting the visibility of workloads to eliminate unauthorized access. Isolating data store for regulatory compliance, such as general data protection regulation. Today's IT environment is rapidly evolving, and the requirements for AWS environment keeps changing. In order to deploy your CDK application into these dynamic, multiple different AWS environments, we should consider 2 things. First, we need to effectively manage the required access and resources to these ever-changing target environments. You will need to create resources such as Amazon S3 buckets for storing artifacts for deployment. IAM roles and policies that grant permission to perform deployment for multiple different environments. Second, we should manage the pipeline configuration changes, such as reordering the deployment sequence or adding or removing deployment stages. And you need to do this every time when there is a need to add, remove, or change the target environments. How we can simplify this multi-environment deployment? How we can automate these tasks without creating multiple complex scripts or performing manual changes each time? There are several different ways of doing this. And using CDK pipelines for continuous delivery of your CDK application is definitely one of them. Okay then, what is CDK pipelines? CDK pipelines is a construct library module for continuous delivery of AWS CDK applications. It allows you to easily create a continuous delivery pipeline for any CDK application, no matter how simple or how complex that the application is. With CDK pipelines, you can simply declare which account and region you want your application to run in, and the CDK pipelines will configure all that at a low level for you, and it will make sure your pipeline in your configuration is set up correctly and securely. In CDK pipelines module, there are many features that enables us to easily manage cross-account and cross-region configurations. Before CDK pipelines, if you wanted to set this up, multi-environment configuration manually, it would be a quite complex operations for you to configure all the required settings for handling permissions, sharing resources, encryptions and decryptions across multiple different environments. And you really need to deeply understand a lot of these security settings to set this up properly. Let's check two features that CDK pipelines provide to simplify these operations. First one we need to check is bootstrapping. Bootstrapping is the process of provisioning initial resources for multi-environment deployment, such as Amazon S3 bucket for storing and sharing files for artifacts, IAM roles and policies that grant permission needed to perform deployment. We can do this with one simple command using Cdk CLI. Then CDK will automatically create all required resources, including multi-environment configurations. Remember that the bootstrap step is required for each and every participating AWS environment when you set up CDK pipelines. Second, the CDK pipelines is providing self-mutating pipeline. This means, what if you add new application stages in your source code or new stacks to your CDK application? The pipeline will automatically reconfigure itself to deploy those new stages and stacks. If you want to add a new environment to existing pipeline, you can do this with a few lines of code in your CDK application, then push the code to the origin repository. The pipeline itself is going to pick them up, modify pipeline itself as necessary, and run all these changes to the pipeline without manual interventions. How we can do all of this in the actual code? Let's find it out with the demo. In this demo, we're going to create a demo pipeline with a simple CDK application with API gateway and Lambda functions, returning the AWS account ID and region that the application is running in. We are going to use GitHub as our code repository, TypeScript as our CDK language for this demo pipeline example. We're going to check 6 steps to see how we can create the pipeline named demo pipeline and deploy the application, and see how we can change the pipeline with adding new environment on the fly. We'll bootstrap the target AWS environment in this diagram, bootstrap the tooling account first, then initialize CDK project using Cdk CLI, set up new GitHub repository, define pipeline using Cdk deploy command. This step is the only step we need to execute Cdk deploy command in this entire demo. Next, we'll create a CDK application, bootstrap dev environment, and deploy that application to dev environment with pushing the code changes to the repository without manual configuration for this new target environment. And we will see how we can add another new staging environment. Here we should also bootstrap the staging environment before push the code and pipeline changes to the GitHub repository. And finally, we're going to add 2 new environments, production and disaster recovery, in 2 different regions. In this stage, we're going to use add wave command so that these 2 environments can be deployed in parallel. Let's see the actual code. First, we need to set up AWS CLI and CDK and create AWS CLI profiles for target accounts with administrator access for bootstrapping. Then we will bootstrap centralized tooling account with CDK bootstrap comment. We're using AWS account ending with number 2586 as the tooling account, and the pipeline will be created within this account. And we'll bootstrap one of the target environments as well. We're using AWS account ending with number 2608 as a dev environment. We need to specify AWS tooling account ID as a trust account within CDK bootstrap comment. After bootstrapping process completed, we can see a CloudFormation stack with the name CDK Toolkit, and this CloudFormation stack creates all required resources such as IAM roles and policies and S3 bucket. Next, we need to set up a remote code repository. We're going to use GitHub for the demo. In order to allow our pipeline to access the repository, we also need to create personal access token from GitHub and store the token in AWS Secrets Manager within our tooling account. We should generate GitHub personal access token with repo and admin repo hook scopes. Copy the token. Go to the Secrets Manager in the tooling account. Click Store a New Secret button. Select Other type of secret. Select Plain Text. Paste GitHub personal access token. Then click Next. Here, we're going to use default secret name, GitHub-token. Click Next. Then click Next. Then we go back to GitHub, create a code repository, and copy the repository URL for the local environment setup. Now open up a terminal, create a directory, create a new CDK project with CDK init command. As mentioned earlier, we're going to use TypeScript for our CDK application with the project name as demo-pipeline. Once the CDK project is created, we need to set up a local Git repository with adding GitHub remote repository that we've just created, and add and commit all the files in the directory and push them to the GitHub repository. Next step is to define CDK pipeline. We can open up a code editor, open demo pipeline stack.ts file from lib folder. Import code pipeline constructs and add a pipeline code block. The remote repository information such as repository name and branch name should be included within the pipeline definition so that the changes from GitHub repository can automatically pick up the changes and initiate the deployment. And then we should specify the tooling environment which the pipeline to be created in, open demo pipeline.ts from bin folder, and specify the target account ID and region for the tooling account. Okay, we updated the code to create an empty pipeline. Let's check in the changes and push to the GitHub repository. Next, we should deploy a pipeline manually once with CDK deploy command. After this, we don't need to deploy anything manually as the pipeline will keep itself up to date from the GitHub repository. Now we can see the CloudFormation stack for the demo pipeline created successfully. Let's check code pipeline from AWS Management Console to see the progress. Okay, we checked the empty pipeline has been successfully defined. Let's create a simple CDK application and deploy the application to our first target, dev environment. This CDK application has an API gateway and simple Lambda function with JavaScript. Let's go to the code editor, create a file as demo lambda stack.ts under leaf folder, and create demo lambda stack with API gateway and Lambda function. Then create a folder called Lambda, create an index.js file in it, create a simple JavaScript code for the API backend, returning AWS account ID and region that the application is running in. And create a demo app stage.ts file on the leaf folder, import demo lambda stack from demo lambda stack.ts file. And update demo pipeline stack.ts file with importing app stage. Set the pipeline props cross account keys as true for multi-account deployment. And add new deployment stage for dev environment with putting the target AWS account ID and region. Okay, then we go back to terminal, checking the changes, and push the changes to the GitHub repository. So far, we created a simple CDK application, registered the application to the pipeline, and added dev environment as a deployment target. After the push, you can see the pipeline is picking up the changes from GitHub repository, automatically initiating the deployment, including the changes for the pipeline itself. Let's go to the dev account to see if our CDK application is deployed properly and working properly. Okay, now you can see the CDK application is running in dev environments as intended. Next, let's add a staging environment to the pipeline. We should also bootstrap the new target environment with CDK bootstrap command. Go back to the code editor, open demo pipeline stack.ts file from leaf folder, and add code block for new staging environment to the pipeline. Let's check in the code changes pushed to the GitHub repository. And go to the AWS Management Console, check if the pipeline picks up the changes, and the new staging environment is being added to the pipeline after existing dev environment stage. Then go to the CloudFormation console and check the status. When it's completed, click API Gateway Endpoint. Now you can see the application is working properly within staging environment. We can check the application is also running in the dev environments as expected. Next, let's add final stages for production and disaster recovery environments. First, we should bootstrap production environment with providing the trust account ID for tooling account. Then we are going to create a disaster recovery environment from different region. In this demo, Seoul, South Korea. Therefore, we'll also bootstrap tooling account and Seoul region to create cross-region support stack within tooling account. And the disaster recovery environments should be bootstrapped as well with trust account ID for tooling account. Okay, let's go to the code editor, open demo pipeline stack.ts file from lib folder. CDK application added to Cdk pipelines by calling add stage will be deployed in sequence, as we checked earlier for dev and staging environment. Here, we are going to call add wave instead of add stage so that both production and disaster recovery environments can be deployed in parallel. We should specify the target account IDs and target AWS regions for each production and disaster recovery as part of production wave. And check in the changes, push to the GitHub repository, just like what we have done so far. Okay, let's go to the AWS Management Console to see if the pipeline updated properly. Here you can see the dev and staging environment deployed in sequence, and the production and disaster recovery environments are deployed in parallel. Let's check in if the application is working in each target region. You can see the production application is running in Singapore region. And disaster recovery application is running in Seoul region as expected. Okay, We went through how CDK pipelines can simplify multi-account, multi-region deployment without manual configuration changes or additional scripting. There are a lot more in this CDK pipelines feature that we don't really have time to show you today. So I hope you will check out the additional resources listed here to gain more confidence and hands-on experiences with AWS CDK and CDK pipelines, and have fun in your infrastructure as code and DevOps journey with using these exciting features. Also, if you want to start your learning journey with AWS training and certification, you can do so by scanning the QR code provided here on this slide. And we really appreciate your feedback so that we can better understand the topics and services you'd like to know more about. So please do take time to fill out our survey and let us know what you think. Once again, thank you for joining me today.